All right, so we're going to use Gauss method to solve this system of equations. We're going to take this system and transform it into a matrix, and we're going to reduce it to reduced row echelon form. I'll explain what that is in a moment. For now, let's turn this into a matrix, an augmented matrix. So I have 1, -2, 1, 8, 2, 1, -3, -9, -3, 1, 3, 5. These numbers are the coefficients of all of these. For instance, there was a 1 there, there was a 1 there, and so on. If one of these letters had been missing, there would have been a 0 filling in the spots. And then these here, they go there. So technically, you're supposed to use brackets. It's fine. Now, I know that I'm finished when this matrix looks like this. You see, this is what we call reduced row echelon form. We have a diagonal of 1s, and we have 0s below and 0s above that diagonal. And these numbers here will constitute the answer. So I need this to look like this, and I'm done. So first, let's create a 1 right here. Conveniently enough, there is already a 1 there. So next step, I need this to be a 0. What we're gonna do, we're gonna go down like this. I need a 1, I need a 0, I need a 0. And then I need this 0, and then that's 0, and then I need these to be 0s as well. So now that that's 1, let's make this a 0. How can I make this a 0? Here's what we're gonna do. We're gonna take row 1, we're gonna multiply it by 2, we're gonna multiply it by -2, and we're gonna add that to row 2. Why are we gonna do this? I am gonna take row 1, this is row 1, row 2, and row 3. I'm gonna take row 1 and multiply it by -2, because if I do that, that will become -2. And when I add -2 to +2, what happens to that number? It becomes a 0. So I'm gonna do this kind of slow at first, and as we go on, we're gonna go much, much faster. Right now, this is what we're gonna do, and we're gonna do this to get the new row 2. So at the end of the day, row 1 is gonna stay the same. Row 3 is gonna stay the same. The only thing that's gonna change is row 2. How? I'm gonna take these numbers, multiply them by -2, and add them to the slot that sits below it. So let's try this together. If I multiply this by -2, it becomes -2. And then -2 plus 2 is 0, which is exactly what we wanted. Now let's see what happens with all these other numbers here. Multiply this by -2, that's 4, plus 1 is 5. Multiply this by -2, it's -2, and -3 is -5. Multiply by -2, it's -16, and -16 and -9 is -25. So that takes care of that. So now what's next? Now I need this to be a 0 down here. So it's kind of the same thing. Let's take row 1, and now we'll multiply it by +3, because if I multiply this by +3, it's 3, and then 3 minus 3 is 0. So I'm gonna take row 1, times it by 3, and add it to row 3 to get the new row 3. So this is just information to the person who is looking at your paper. This is you telling them what you are doing. But let's see what happens here. So I know that row 1 is gonna stay the same. I know that row 2 is gonna stay the same. It's just row 3 that's gonna get switched. How? Well, let's see. Multiply row 1 by 3 and add that to row 3. So multiply this by 3, and that's 3. Minus 3 is 0. Multiply by 3, it's -6. -6 plus 1, -5. Multiply by 3, it's 3. Plus 3 is 6. Multiply by 3, that's 24. Plus 5 is 29. So I have the 1 and a couple of zeros. Boom, boom, boom. That looks good so far. Up next, I want this to be 0. I want that to be 0. So I need this to be 0. So what I can do is I can take row 2 and add it to row 3 to get the new row 3. And that works because if I add this to this becomes 0. So let's set this up here. I know that row 1 stays the same. Row 2 stays the same. It's row 3 that's going to change. So let me add row 2 to row 3 to get the new row 3. So this plus this is 0. This plus that is 0. This plus this is 1. This plus that is 4. That's looking good so far. Let's go back to the chart. I need a 1, 0, 0, which I have. I need a 0 here, which I have. Now I want this to be 1. Right now it says 5. So what you can do is you can look at row 2. Well, let's take row 2 and let's multiply it by 1/5 to get the same, or to get the new row 2. So in other words, divide each of these numbers by 5 or multiply by 1/5. It's the same thing. And you have permission to do that. You have permission at any point in this process to switch any 2 rows. You have permission at any time in this process to divide or multiply a row by any non-zero number. So right now, I feel like keeping everything the same except for row 2. I feel like taking row 2 and multiplying by 1/5. If I multiply that by 1/5, still 0. Multiply by 1/5, 1. 1/5, -1. 1/5, -5. That was really good because now I have that 1 right there, which is right here. So what's next? Now I need a 0 above it. To do that, what I can do is I can take row 2, I can multiply it by 2, and I can add it to row 1 to get the new row 1. Because if I multiply this by 2, I get 2. Add it to that, gets a 0. So let me take that upstairs. This process, it's a bit messy at first, but the more you do this, the faster you get at it, and the more you'll like it because it really is a time saver. So anyways, I know that I'm going to keep the bottom 2 rows the same. It's the top row that's going to change according to this. Multiply the second row by 2 and add it to row 1 to get the new row 1. So if I multiply that by 2, it's 0. 0 plus 1, 1. Multiply by 2, 2. Minus 2, 0. Multiply by 2, -2. Plus 1, -1. Multiply by 2, -10. Plus 8, -2. What's next? I have my 1, 0, 0. I have my 0, 1, 0. There it is. I have a 1 here. Now I need both of these to be zeros. So why don't I do this? Why don't I go row 3 plus row 2 to get the new row 2? Bottom row stays as is. So row 3 plus row 2 to get the new row 2. So this plus that, 0. This plus that stays 1. This plus that, 0. This plus that, -1. Keep the top the same. We can take baby steps. We're not going to rush this. So now the last step, the only thing now I need is a 0 right there, right here. So to do that, I'm going to take row 3 plus row 1 to get the new row 1. And that should finish the problem. So keep the bottom row the same. Keep row 2 the same. So now add row 3 to row 1. So this to that, 1. This to that stays. This to that, 0. And then this plus that is 2. So here I have my final answer. So x, y, z, which by the way was the goal all along. Remember that? So x, y, z equals 2, -1, 4. Or more traditionally, x, y, z equals 2, -1, 4. If you had extra time, you could plug in x, y, z into x, y, z, x, y, z, x, y, z, and you'll see that this ordered triple satisfies this system of equations. So this method here is called Gauss method, the reduced row echelon version of Gauss method.